All right, here we go. I think we're going.
And I should see here too, huh?
Possibly.
Cool. Let's see. And when did you publish the link?
Yeah.
On the forums. Okay. Let's see. Application. Announce. So we're offline.
Or is it on the Eventbrite?
I put it in the forums. So
For the forums.
Put it on Eventbrite too. Although it's not that's kind of late, but
I can.
maybe the Vermont guy.
I sent him
right now. Damn
I
it.
sent him an email with the director. Hold on, let's see.
All right, let's see. Boston D Meetup, Strawman. Strawman Structs. Maybe it's related to that kind of stuff.
It probably does actually relate to that. Let's see.
I thought that's related somewhere. No, either.
No, it has to do with yeah, it's
All right, so this is what you should see. This is what you should see on the.
Cool.
Huh? I'm started. Yeah, it's going.
Website.
Is it working?
no, I said just the moment.
Oh, there it is. All right, it's delayed.
It's a bit
So
late.
it should be. Is my chat? Can you get the chat window? I don't know that it's too important, anyways.
One watching now.
Which is you probably. I forget this.
Where did you post it in the Jumbo? Or announce?
And announce under my.
I haven't checked the forums in the.
Oh, there it is.
So how do you get to the chat window?
All right.
Boston D, Strawman Struct.
Yeah, I got the chat. Do you got the chat window?
No, how do you get to it?
It's in the bottom.
Oh, wow. Oh, you can do live on YouTube? This is fantastic. Do you have to pay anything to do this?
No.
For YouTube? Really?
Nope.
Free?
All right. So
Oh.
have about 5 minutes of us trying to get it to work.
No,
Recorded.
I'm on.
I can hear it too now.
Wow.
All right, good. All right, so Strawman Structs. I'm going to get into what they are, but to understand why I discovered them, I got to give you a little bit of background.
What the heck is Strawman?
Oh, it will come out. You will find out. It's like slide 5 or 6 or something.
See, not yet. No, I'm serious. Are people hearing?
Yes,
They are?
they should. Well, it's coming through my. So as long as the microphone can reach your voice reaches the microphone, then they should hear it. All right. So, so in order just to kind of describe what they are, to kind of show you how I came about figuring these things out. So everybody's. Whoa! There it goes. All right. So. Serialization via user-defined attributes. We all understand this pretty well, right? So you have a struct, you want to serialize it. A very nice way of describing to the serializer, this is what I want you to do with these things, is to use user-defined attributes. So right here we have, the ignore attribute is basically saying don't serialize this data. This optional attribute can apply to multiple things. So you could apply attributes to multiple things. It's a very nice, easy interface to say, this is how I want you to deal with this struct. Huh? Oh, just wait. Just wait. You'll like this. And then, of course, you see like column name body. So basically, the body keyword is probably going away eventually.
Oh, yeah.
But right now, it is a keyword. So we have to define our struct with the underbar body. But in the database, it might actually be body. So
is this something like SQL Alchemy or Quirky or something?
maybe. I don't know.
Is it like ORM?
It can be like an ORM. Yeah. It could be. It's basically instructions to the your serializer on how to take a row and build a struct out of it. All right. So I kind of made these up. They ignore an optional kind of from like vibd JSON serialization, but the column stuff. But anyways, so I get to show you my hacky. This is my internal application that I have at work. That I wrote a kind of a serializer for MySQL. So I wanted to have a namespace. So I use a struct as a namespace, and then all my attributes are here. We have one that says, okay, you got data from a row. You have a column, and it matches some member in the struct, but I don't want you to actually serialize it. So that's the exclude attribute. Require means if you didn't get this, if for some reason you try to serialize this row and it doesn't have that column defined, then you're going to have that's a compile time error. Or not, it's a runtime error, but it's a.
I thought that's always the case. That should be always.
So what I actually have it so that it will just serialize the pieces that you selected from SQL. And the reason I do that is because a lot of times I'm not getting the whole thing. I'm just interested in pieces of it.
Well, a primary might be another example. Like, it's a primary key, can't be
right. You can't be. It can't. You have to have that in there exactly. So and then we have a template for a column name. So we're going to rename this column. It's the column name is different from the member name, and column prefix says, well, I have this prefix that to use the member name, but or the column name that you've used, but prepend this piece to it. You'll see.
You go just a slide back.
Yeah.
Column name.
So this was just like
because
this is just made up.
You would need the bank.
Right. So that was just like a
I see the
just to demonstrate, certain things. This isn't actually what I use.
Right.
Those are made up, but this is the actual stuff that I use.
I understand the design thing. Those are decorators.
I'm sorry.
Also decorators.
They're
like
attributes which
attributes,
decorate each declaration.
Yeah.
Each declaration
Right. So
number.
at compile time, you can get this information.
You write them in your code, and you can get them programmatically for any
through introspection.
Yeah.
Right. All right. So and I have a whole bunch of other stuff, but you get the idea. So let's see a usage example. So let's say I have a person table in a database. ID is straightforward. Username straightforward. In my database, password is actually the hash. I wanted to rename it for my struct. I didn't want the database defines it as password, so I wanted to define a password hash so I don't screw that up. The idea of that, and status is actually a character of one width, so one character. It's either an A or an I. A means active, I means inactive. So. So the way I serialize it, I say, okay, well the column,
everywhere, man.
the column type is actually a string. So what you get back from the database is actually a string of one character, A or I. But I have a special parser that reads that and says, okay, if it's an A, then it's a true. If it's an I, then it's a false. So I basically can just annotate this and this. Oh, I know how to handle that. And then a bunch of strings that pretty straightforward.
That particular attribute has type pointer to function.
It's an alias actually.
An alias of a function.
Alias of anything. So it could be a function, functor, anything. It just takes an alias like that.
Just invoke it.
Yeah, just as if right.
You can have multiple
attributes of any number, arbitrary.
Right. Yep. So it's here. Now the only annoying thing about having that namespace is you have to close it in parentheses, otherwise it doesn't work.
But can't you put the ampersand, close paren, space?
Yes.
Right?
Yes. And you can nest them too. So you could have, I'm going to put a bunch of these. I can do an attribute with a open brace and apply the attribute to all these things.
Oh, I see. But I thought
just like normal attributes, just like cons, pure, all of them.
Nest, and at that point I thought, hey, maybe you can have an attribute. And inside we have an attribute that declaration.
An attribute of the attribute.
Yeah. I know you like attributes. So you talk.
I don't know if you could do that. It's possible. But anyway, so this is kind of how I use it. So dbcon is a connection. I call this function fetch, which just takes some SQL, and as I and then it returns a range of rows.
That's fantastic.
And then I say byItem, which is my serializer, is going to take the rows, and instead of giving me a range of rows, it's going to give me a range of person structs. So I just directly read them lazily exactly as they come. See, like here, I'm looking for people who have a yahoo.com address. Right, so it kind of makes sense, right?
No, yeah.
Very nice.
One thing I was wondering was the password hash is string, but we don't have a column associated. That means it's not registered in that.
No, the column is actually password. It's named password. But I wanted to use the term password to mean the actual password, not the hash.
Just change.
I just changed the name from password to password hash. That's all I'm doing. The column name is password. The member name in the struct is password hash.
No, but
that's all.
Why is it that the active has column type and column name?
Because those are different attributes that not only is it a different name, but it is a different type. So it's not a bool stored. There is no bool type in SQL or MySQL. I think
Yes,
they're
mapping.
my
It does a mapping from whatever is in SQL.
right. It's actually a character of one length.
Can you associate it to, because you have like bool active and bool, what's the other I?
I see.
What was the I?
Active or inactive.
Inactive. Okay, what if you have a character that describes like 4 possible states or whatever?
Then you would write
Boolean.
so I wrote that set AI Boolean. You write a different parser that would.
But I mean, can you associate 2 fields with the same column in the database?
I don't see why not.
Destroy Steve.
I don't see why not. But I mean, the focus the focus is not on the database serializer, ironically. But this is just to give you like kind of background of like where I came up with this.
Yeah, no, this is.
So one of the things that I'm going to show you here is what byItem does. So byItem is a IFTI template, but it's 2 templates nested together so that I can use IFTI on the parameters, but then also pass some
Sorry, what is IFTI?
implicit function template instantiation. So basically, you give it it's in C++ too. You give it
Something happened with the transmission.
oh well. Sorry.
No, it's coming back.
It reappeared. So if you have a function template that takes one type parameter, you don't have to say, if you say foo of 1, you don't have to say well, foo bang int 1. It implies that it's an int.
And that's nifty. And it's nifty too.
It's very nifty.
Nifty.
IFTI.
You know, one thing I'm realizing when I'm
Implicit function template is that.
trying to use Bleed for the programming, there are so many new things that not all the programming languages have.
Well, this is actually in C++.
Okay.
Like make pair, like you have make
More
pair,
recent, okay.
you know, that kind of a thing, you know. So, but here we have a template nested in a template because I want to use IFTI in the sequence, but I need to use a variable, a tuple for the types. So this takes any number of types. The more types you give it, the more it's going to return a range of a tuple of all those types.
But wait, I mean, I see you have, sorry, I don't have regular code. Yeah, okay, cool.
Right. So first we get an alias of item types. So this is all the types that could be in that tuple. And then I get an alias of past descriptors. Those are all the descriptors that can be in that tuple. I'll get to what a descriptor is in a second. But basically, so the past descriptors are all the descriptors you passed into that function. And the types are iterated that way. So then inside here we have, if the past descriptors, if there's no past descriptors, I'm just going to use the attributes inside the types themselves to create descriptors. The descriptors say, serialize it this way, right? Otherwise, I'm going to use the past descriptors. And then I create my range and return it, etc.
Go back to the usage of byItem first. Okay.
So this is actually using the DB call name and the DB call type and everything to create the descriptors on how to parse the data out of the code. All right, so this is what a descriptor is. Basically, you give it a type, you give it item index or which index into the tuple that you were talking about. What's the name of the member, the name of the column, whether it's required or not, and how do you parse it? It's a template namespace that just has enums and aliases. There's no actual type here. It's just a template.
We have alias inside of the template.
So you can do a field descriptor, bang, whatever, and then dot parser, and that's the parser that it will use. By default, it uses parse mem, which just says get the name out of the struct, and I'm assuming the column is there, and I'm assuming the type is the same, et cetera, et cetera. So that's the default. If you want to change it, like the parse AI bool or whatever it was, then you pass in an extra one. And the byItem generates these descriptors from the attributes that you put into the struct. So we kind of have an SQL join problem. So if you have, let's say, an struct organization, which is also in my database, we have a struct person. Now, if you look down at the bottom, you see there's a relationship, right? We have a primary contact ID. That's an ID of a person. So if I wanted to get a list of organizations, and at the same time, in each row, I want to see the person's, let's say, name or email address or something like that, right? Then I can use a join, right? But the problem with just saying, give me all the person columns and all the organization columns is, okay, we have conflicts, right? That both of them have IDs, both of them have address, city, state. Right. So how do you parse the right one into the right spot?
Some, table dots, whatever.
Right, but it doesn't come out that way, right? It comes out. It comes. You could do it by column order. You can do it by column order, but if you do it that way, then you have to know the exact column index,
which is fragile.
Right, which is fragile. So here is like my SQL for getting all the organizations based on some criteria, but then I'm also going to left join a person, and then up here you see I'm renaming.
Yeah.
P address as P underbar address, P city as P underbar city, etc. So that way I'm resolving the conflicts. So I have one state and one P underbar state. So you get how that works. Now, like an ORM might do this by first downloading the organization and then going back and saying, oh, here's a person ID. I'm going to go download the person and build my struct. You could do it that way, but the problem is then you have more round trips. You're not doing one SQL statement to get it all.
But with your byItem here, it's going to be, what's the argument to byItem?
So the argument to byItem is organization person. And then what will happen is
two, comma.
Yeah, it just returns a tuple. So now your front is a tuple.
It's awesome.
It's pretty cool. I know
everything now.
Yeah.
Ask me questions. It's pretty awesome.
So you could do multiple selections, but then if you were selecting like 100 organizations, now you got to do 100 more queries to get the person. So I like to get them all at once in the same row, and I'm doing it lazily. So, but we need to tell byItem, hey, that city is not, that city field. I don't want you to get city. I want you to get P underbar city.
Yeah.
But we've already created our field descriptors based on the attributes. So how do we fix that? So one way to do it is, remember, we can pass the descriptors in directly.
That's why you have that static.
That's why I have that. That's why I have that static if. So you can actually say, okay, I'm first going to imply that descriptors tuple. I'm going to imply the organization, the correct description for the organization. But for the person, I'm going to say, okay, actually, the ID is actually PID. The username is the same. Actus, all that crap. So I'm basically writing if you think of the descriptors as like assembly instructions, and the struct itself is like the high-level code, and this descriptors tuple is like the compiler generates the field descriptors from the high-level code, then I'm like writing assembly here, just so I can get around that. So I thought about it, I was like, there's got to be a better way to do this. So this is what I came up with. Instead of passing the person, I'm going to create a separate struct that I'm not even going to use. I'm just using it as a way to generate the descriptors, right? So here I could say, okay, those things I'm going to put a prefix in front of them, and the rest of the stuff, I kind of copy from the other one. And I also don't have to talk about all the other columns because I'm not selecting them, right? I only selected a certain amount of columns from the person. And this is how it works. So I say for each organization person in the range, which was the range of rows, by item, here's my 2 types that I'm going to do. Now I have to redo this.
0.
So the 0 is so that when descriptors tuple has that, remember, has that index of which type am I talking about. So that basically sets it to say, okay, if you only wanted to describe one of those, you would pass in, you know, a 1 or a 0 or whatever. This is the type I mean. I did not spend any time on making this like the original stuff was just what was it? This. I just said this descriptors tuple I thought was just going to be an internal thing that I generated on my own, you know, that I wouldn't use it. So I probably could make this API a lot better. But
is filter a built-in?
Filter is in std.meta, I think.
Filter.
Yeah, there's some meta.
Capital F.
Yeah, capital
Oh,
filter.
yeah.
It basically takes a template and only gives you a tuple of the things that pass that template.
Alias.
Yeah, an alias sequence, right? So here we just basically replace the, you know, instead of just passing the organization person, we pass organization and person strawman. We're still getting person objects, so I can use them in all my other code that expects to have person, but I don't have to rewrite person or do that whole crap with generating the field descriptors myself. I let the compiler do it for me, or my thing that I already have built that generates those. So this is a really nice thing, I think. You know, basically I kind of defined a Strawman struct as like a struct that's only used for purposes of introspection. You're never right. You're never instantiated ever and one ever.
It's you're literally the language as
like a DSL kind of thing.
Yeah.
You know.
It's gonna parse the thing for you. It's gonna store it
Right.
the metadata about that struct, and you're using only the metadata.
Right.
You never
Exactly.
use it as.
Exactly.
But let me make this. I mean, this. There would be a simpler engineering approach, like you go string to string. It's like color mapping for.
Yeah, you could do that.
So, you know, during compilation.
Right.
You can pass it as an argument.
Yeah, you could
by
pass
item.
you could pass this whole thing as a string too. I mean.
Yeah, I mean, yeah, but the advantage would be that the hash table would only need to include stuff that's different from the defaults.
Well, I could do that too. I mean, part of this was just a discovery. It wasn't like something I planned on. So I could make an API that says it's just like this, but change these things.
With these things,
you know,
changed.
Right? Because I could write a different function or a different template besides descriptors tuple that would do that.
Because
So
it's like really, it's like there's a lot of what's the word? There's a lot of moving pieces. Like you're
Right.
using out of language features at the same time.
Yeah.
People need to kind of follow exactly what's going on.
Right.
And the second question I had was, what if you have? Could you go back to the SQL query? So what if? So I see p.id equals or primary contact ID,
Mhm.
and you want to, let's say you want to put, let's say both have a field ID,
Mhm.
and you want to distribute that column ID to both structs. Is that possible? So you want to duplicate.
It's absolutely possible. I don't know that my code will work that way, but I could make it work that way.
Okay. Because sometimes you do need the ID map, present map, like for like the search that it's not zero and that kind of stuff. So,
Yeah,
you know,
yeah, definitely.
You want it duplicated across the two structures.
Yeah, I think I don't know that it would work right now. Like if I may have to change it.
But it's a reasonable thing.
But yeah,
Okay.
definitely.
And you're not talking about shared memory.
No. It's simply that, like even in SQL at SQL level, when you operate, you end up with sort of the same field duplicated in a couple of views and stuff like that.
Right. And a lot of times ORMs will dictate, you have to name it this way so that it'll work right.
Exactly.
Whereas this kind of gets around that because I had an existing database I had to write code on top of.
Are there any existing ORMs?
I think there are. Yeah, I think so.
This is
They're-
interesting.
Again, this is
really
Yeah.
out there.
So I thought about this and I said, okay, what?
Can I ask a question?
Sure.
What's this inside the struct? You have something that almost looks like a struct. Is it like a scope? Scope.
So I've applied that DB call prefix
So you could
attribute.
have this return
It applies to each one of
separate
those.
lines.
So when you go through it, it's as if you type that on each
Each of them.
declaration.
Okay, that's great.
That's
I
how that
love
works.
the compression.
Yeah,
It's
that
fascinating.
it's really nice way to
Yeah, I love that.
make
Oh,
that.
and here's the question. Yeah, I think I realized what would be the advantage of the hash table. Because the hash table, you just need to specify the delta, whereas here we rewrite the whole struct. Can you do a struct that's diff,
Correct. Yeah.
a patch?
Because remember this
You know,
this
for the-
is just
the other
the tuple, right? This is the thing. It's
Oh my
taking
goodness.
that and it's just generating all those field descriptors.
Like
I
first
could
name and
I
last
could
name.
take this and say, okay, generate all the field descriptors from this guy, but change these ones from this guy so that they overlap.
Yeah,
And the
so that-
result would be a different set of field descriptors.
Right, look at first name and last name. They're
Yeah.
identical with person.
Right, exactly. First name, last name, email. So like I said, I didn't spend any time making this like a really nice to use feature. I just noticed that I could do this and it's a lot easier.
That would not be a Strawman, it could be kind of a patch.
Patchman, right?
Patchman.
Patchwork guy. All right, so so I thought, what other things could be useful for this concept of Strawman Struct? So I thought of this other idea. So we have template constraints, right? This is kind of the old,
Nice, yeah.
the old
Yeah.
is information. I don't know if the new one
It's a
is.
shame that it's on the slide, man.
I don't know.
On
I
the
don't know.
slide, I mean,
I think the new one is in progress, right?
that's the old-
It's
that's the
Oh,
old-
it's not in use anymore?
yeah.
But
in any
works,
case,
but it's just
It works. So, but you kind of have to infer. It's got comments. You kind of have to infer. This is what this means, you know,
okay.
based on I wrote this code and only some.
Tell us.
Yeah.
We're
Okay.
eager to figure out
Right.
your idea.
So, what about instead of using a strawman struct? So let's say we had this strawman range, right, of some type, and we say you can read. This is a property you can read. This is a property you can, empty is a property you can read. You can call this function pop front, and basically you replace your is input range with this function implements that would return true if the R implements this strawman range, right? So the reason I like this is it's self-explanatory. You generally already have in the documentation. Here's what a dummy range looks like. You just take that and say, use that as describing how you, and basically this implements function would generate that set of constraints, or the new set of constraints, or whatever it was, based on what you attributed in there. And I thought of this any type, which would basically satisfy the things like you could say a strawman range of any, and then it uses auto instead of whatever the type really would be. But you could say something like only foo maybe only accepts a range of int, so you could say strawman range of int. It would be the similar type of thing. Does that make sense?
I think I just peed in my pants a little. This is awesome.
So what does it look like?
Very interesting idea.
Also, it kind of reminds you of C++ concepts, doesn't it? Like
Yeah, but without any syntax, which
Without-
is
right.
a huge difference.
right. So this is the concept.
Right.
Make your stuff look like this.
Yes.
It kind of makes a lot of sense. All right. So this is like my hypothetical. This is like my hypothetical constraint API that I haven't written any of this. It's just was an idea. Like any type is basically a specialized. If I see that this is any type, that means I'm going to assume that doesn't figure into whether it can accept it or not. It can be any of the types.
Last signal again.
And then you could parameterize that possibly. If you had multiple any types, you could say this any type has to be the same as this any type.
Right.
So, and then we have like read property, write property, or rewrite property. Basically, it would generate the right, constraint to say assert, I can read this property out of it. call, make sure the function can be called, require certain attributes maybe. One of the things you have to watch out for is when you build your Strawman Struct, if you provide an implementation, the compiler is going to infer a whole bunch of attributes. Like if you just provide like a dummy implementation, like for what is it, like pop front, if you just had it do nothing, it's going to say, oh, that's pure, it's const, it's all these things that you don't really want to say is like the what it is. So maybe you have that.
The following problem.
Yeah.
Let's say equals. So you have templates. Is it equal or equals? Equal. A equal B, right? That template says, well, both operands must be input ranges.
Okay. Yep.
And their respective element types must be comparable.
Correct. So you could extend not any, but maybe have some more descriptions of like.
Yeah. So maybe any don't even need. Could you turn back one slide?
Sure.
Yeah. Implements bang are comma Strawman range close paren. And in that case, implements takes an alias as its second argument. And if you don't, if it's a template, then it assumes it means any.
Right.
There's no need for an actual.
But you have to instantiate it to introspect it, so you would have to.
It's gonna be its own level, right?
It could be an internal thing that you do.
Yeah, it could be an internal.
Could be an
thing.
internal thing. For
Okay,
sure.
so then in that case we would have something like, well, okay, so implements are one input range of whatever. Implements are two input range, and then element type. So that there's no saving there, right?
I'm not 100% sure because you could say Strawman range bang T and then Strawman range whatever.
Yeah, but you need a T to be deduced. You want unification.
Right. It would be any, and then the second one would be some
same
other
same any as before.
either the same any, right?
It's not the same.
Or it would be some way to say this could be. This got great. Oh well. Anyways, we don't have any comments yet, right? I don't know if anyone's watching.
Oh man, they're missing out. This is a great. This is. I mean, it's like 3 or 4 great ideas.
Okay, so there's so many things that can be introspected besides that, you know. But whatever you need to override, you could say. But like imagine you could say this. Just put disable this, and then the thing knows. Oh, it's not copyable. Now I can I can introspect that. I don't need to. I don't need to put any special, things for that. So some other benefits, if you have that implements function, let's say all nice and buttoned down and tested and everything, we don't have issues where somebody's handwriting these range constraints or constraints and screws up one. Like I think there was one where checks to see if range save returns the
Actual range.
the given range, and it was done with is type of range.save, which turned out to be, if it wasn't a property function, it turned, so stuff like that is right. So stuff like that is difficult to see right away if you're doing that. But if we fix that, let's say we had that problem, we fix that in implements, it's fixed everywhere. So you have one place where you're fixing all these things. Easier to comprehend, obviously. You could have DDoc on these things.
That's a very nice tool for writing archetypes.
Right.
Archetype is.
Think of this too. If you ever have a thing where he's like, I swear.
Archetype, what you said? Archetype. Archetype.
So let's say you had this struct that you wrote, and you try and call some function on it.
Yeah.
It says, oh, that's not a range.
I'm thinking,
oh, it's just a freaking range. I wrote it. It has front, has empty. How come it's not working? In order to figure out why it's not working, I had to do this in the past. I take the lambda and I actually copy that somewhere and I try to call it with this to see what the compiler is complaining about.
How does implement help you with that? Maybe we have a
because maybe you have a separate function. Describe issues. Why is my struct not the same as this one? How come it doesn't work?
Okay.
And it could tell you a nice listed errors. This is a problem.
Okay, and that reuses the prototype. The
Reuses
archetype, sorry.
reuses the archetype, right?
Hey, this is the very like ranges are not very complicated, but a much better, not much better, but sort of a killer application is the allocators concept.
Right.
Because it's a
Yeah, you could use that
it's a hefty
for this to say, you know, are these
and
the
you
same?
can have an attribute optional because most functions are optional in the allocator. You say optional realloc.
Yep.
And if it's not present, it's okay. But if it's present, you must have the signature.
Right.
That kind of stuff.
Yeah, you could do stuff like
Oh
that.
wow, that's awesome. That's different.
And then this other idea I had is like, you know, let's say you have a struct that's not a complete. It's not a complete range, but I want to make it complete
That's
with whatever.
the whole patch thing, right?
Yeah, like
Okay.
add enough methods so that it passes the is a range, and then I can use that as another type that I try like a test on. As a black hole, we know what that does. It implements everything that you need to implement for an interface, but in this case, it's like a duck type or whatever. So, and that's it. That's all I had. You know, for right.
Strawman.
So
that's awesome, man.
Where did you get this idea of the whole strawman thing?
like I said, I was playing with my
Like a voice.
with my my database serialization. I was like, how can I make? I ran into that exact issue. It's like I want to pull both of these tables out. How do I make that work? Because I've already attributed everything.
One of the reasons this intrigues me a lot is related to what I did 10 years ago. 10 years. So what 10 years ago I did was we were putting this natural, we had all these different annotations for data, and there were a lot of interactions between different annotations. And so I decided to put everything in the database. Because in a way, I sort of shot myself in the foot doing that somewhat. But and that was, I think, before warrants were really available. So I had written like a lot of boilerplate code to read and write from a database table, then create objects and write the database, create objects. And this might fit really well in it.
Yeah, in fact, when I started writing the database code, I had resolved like I don't want an ORM, I don't want to do all this serialization stuff. I'm just going to write the code just like you said. I started doing it. I was like, no, I can't do this. I gotta write some attribute parsing thing because there's no way I'm gonna do this for everything because I had so many tables.
One thing that I love about one of the ORMs, I think is Pony ORM. I don't know, it's not very popular now. But it's kind of wraps SQL in functional paradigm. So it takes functional. Oh
yeah, you could basically generate SQL statements from.
So you write generators and
right. Yeah.
It generates SQL.
I think MySQL native does have some stuff like that, but I'm not.
Does Attila Neves know this work? Attila.
Does Attila know? No. It's the first time I've shown this.
He's gonna pee his pants.
Attila, if you're watching, don't pee your pants.
He's not watching apparently because it's like 3 including ourselves.
It's probably just us.
So this is gonna be recorded, right?
Yeah, it's recorded now. It should be online. All right, thank you everyone for watching.
Amazing. You're sending the slides, right? Slides are
What?
available somewhere?
There's not much to the slides, but I go. Let me just see.
Is this
Where am I here? Yeah, it was this keynote.